Hello everyone. Today we're going to look at the Pythagorean theorem, and I know for most of us this is just going to be mostly a review, but we're going to look at it in a couple different ways that just kind of extend our understanding of the Pythagorean theorem. So here we have the Pythagorean theorem, a squared plus b squared is c squared, where c is always our hypotenuse, and our hypotenuse is always across from the right angle. So I look where's the right angle, I make a little arrow, that's C, that is alone on the equal sign. A and B are added together on the one side of the equal sign. So a squared plus b squared is equal to c squared. And again, this is the Pythagorean theorem, which we've had looked at before. So what I want to do is just take a look at a couple examples. So down here, if we look at number 2, what I'm going to do is I'm going to go and identify my right angle. Here it is, and go right across. And this is C, so I know that I will have x squared plus 19 squared is equal to 21 squared. And again, this is because I'm using A and B, and we know that a squared plus b squared is equal to c squared. So really the key is identifying which one of these is our C, and then we know that that will go by itself on the equal sign. That way we can just keep all of our ducks in a row here. Okay, so just going through this, x squared will just remain x squared. X squared will remain x squared. 19 squared is 361, 19 times 19, and 21 times 21 is 441. And then we can subtract this from both sides. We find x squared is equal to 80, but we don't want to know what x squared is equal to. We want to know what x is equal to. So this is the step where we square root both sides, and we find that x is equal to approximately 9.8, or your calculator might return square root 4, or 4 times the square root of 5. Later in tomorrow's lesson, actually, we'll be using these values. So this is, again, just a very basic Pythagorean theorem example. But if we look down here, we do see some more interesting examples, to say the least. So how can we find the measure of x? Well, what do we have here? We know that these hash marks mean that both of these are 19, so I know that this hypotenuse over here is 19. I also know that if this is a right angle, then this is a right angle. And so this turns into C. And notice what I have here. Oh, 17. 17. That's got to be the same length, right? So we can use our Pythagorean theorem. So here we have just this triangle right here. It's a right triangle. How about green? So this triangle here in green, it is a right triangle where our hypotenuse C, right, because this is across from the right angle, going to my right angle, then going across from the right angle, this is the hypotenuse. And so my unknown side down here will be this side. It will be x. So it'll be this side right down here will be our unknown. We can just call that x. And so we'll have x squared plus our other side in purple there, which is 17, and that's going to be squared. And then it will be equal to our hypotenuse C, which is 19 squared. So we have x squared, which will just say x squared. 17 squared is 200 plus 289. And 19 squared is 361. And again, we can just subtract this number from both sides. We find x squared is equal to 72, but we want to find x, not x squared. And so we're going to square root. The square root undoes the square, and so we get the inverse operation will result with just x, and x will be equal to approximately 8.5, or 6 square roots 2. Okay, so let's use 8.5 here. Oh, we had 2 x's. That might be a problem. That's okay. We're just going to replace this blue number here with 8.5. And then this one over here will also be 8.5. And so really we want to find this measure here in orange. And so I know, let's call this one, oh, this one is x, right? And so let's just make a little, because this one will be x because these two are the same. Let's just make a little equation. So if I'm looking at this entire line segment, I will have 8.5 plus x plus 8.5. And what's the total measure of this whole line segment? Oh, it's 31. And some simple algebra here. Add these two numbers together, subtract that number from both sides. We find that x is equal to